All right, we're going to look at our parallel example. So we just learned about how to identify a parallel circuit, meaning there's one resistor per path and there's multiple paths between junctions. So our example here, we have junctions where we have 3 or more kind of wires going into it, and it splits. And if I take each path until the next junction, if there's only one resistor on each path, and there could be 2 paths, 3 paths, as many paths as you want, as long as there's one resistor on each path, those resistors are in parallel. All right, so let's go ahead and review those parallel rules we're going to apply here. So to find the total resistance, I have to go 1 over R total is equal to the sum of all of the inverses of those resistances. Now you can write the equation either way. This is the way I tend to type it on my calculator. This is the way I tend to write it out, so it's a little more visual. Yes, it is in the denominator there. The total voltage is going to be the same for all of them, because if I think about it, if I remove this resistor, I only have this 16 ohm resistor in here, it's getting that full 12 volts. If I remove the 16 ohm resistor, the 20 ohm resistor is getting that full 20 volts, meaning one path from that battery goes through the resistor. There's only one voltage drop along that path, and so it gets all the 12 volts. No matter which path I take, there's all the voltage drop through each of those resistors. And lastly, the current is the sum of all the individual currents. So at this junction, we'll see that current split, and it'll go parallel, hence the name, through those 2 resistors and then combine back up. So the total current is the sum of those 2 individual currents. And so again, we have the same voltage. We're going to find those currents individually. Okay, so when we're thinking about this total equation, we're going to use this total equation to find like R total, V total, I total. And then we can use that V total to say the same voltage all the way through. Use the individual resistances, the individual voltages to find the individual currents. All right, so let's give this a shot. So the first thing they want me to do is find the total resistance. So we have already kind of gone through that, identifying that this is in parallel because we have a junction and we have one resistor per path and multiple paths between junctions. We're in parallel. And so I'm going to go ahead and say R total is equal to R1 inverse plus R2 inverse, and inverse that. So I'm going to type that on my calculator as R total is equal to what? 20 inverse plus 16 inverse. So let's go ahead, let's look on a calculator and see where do I get this inverse key and how is this going to show up on my calculator. All right, here we are. So we're going to show you how to use this inverse key to do this calculation. So how we type this in is we type in, we got to open up a parenthesis for that final inverse, and we're going to type 20 inverse plus 16 inverse, and then we have to close that parenthesis and do the inverse again. And again, that inverse key is right over here on the left side. Go ahead, hit enter, and there is our 8.888 or 8.89 ohms. Back to the board. All right, so there we go. We got a total resistance, our total here, of 8.89-ish. Okay, 8.89 ohms. I'm going to store that on my calculator if I need it later. All right, the second thing they want me to find is the direction of the current. Current always flows from the positive to the negative. So here I'm going to start the positive, and it's going to come here, and it's going to split. Part of it's going to go through R1, the other part is going to go through R2, and then they are going to combine back up. So that is the direction of the current in each of those paths. Now we need to find the voltage across R1 and R2. Good for us. It is in parallel, so that means those voltages are going to be the same as the total voltage. We already know the total voltage, so we know those two are going to be the 12 volts. All right. Next, we need to find the current in each resistor. So current, we're going to be using Ohm's law, and we're going to find those individually. So current from Ohm's law here is equal to voltage divided by resistance. So I1 is going to be V1 over R1, and so I have 12 volts in each one. R1 is 20 ohms, so I get 12 20ths, 0.6 amps. All right. I2, it's going to be V2 over R2 is going to be, what was it, 16 20ths? All right, so that is going to be what, 4/5? Nope, 3/4, sorry, 0.75 amps. 3/4, 0.75 amps. And so then my I total, I can find my I total, which is my last step here, find the total current one of two ways. I can either add up the currents of all of the individual parts to get the total current, or I can use V total and R total. Either one should give you the same number. So if I put these two together, I get 1.35 amps as the total current. That is one option by adding those two currents together. The other option is I total is going to be V total, which is 12 divided by R total, my 8.89, also gives me the 1.35 amps. There you go.